Welcome to Study Loop.
For this problem, we have been told that we have two sets, A and B, and these are finite sets. In other words, there is a fixed number of elements within each set, and the cardinality of the two sets are equal. So the number of elements in set A is equal to the number of elements in set B. We're also told we have a function going from A to B. What we want to show in this problem is that f is 1 to 1 if and only if it is onto. So we're going to go both ways. We're going to assume that f is 1 to 1 and show that that means it has to be onto. And then we'll assume that f is onto and show that it has to be 1 to 1. Now, before we do that, though, let's do some definitions. What does it mean if a function is 1 to 1? Well, a function is said to be 1 to 1 if and only if we have f of a equaling f of b, that implies that a equals b. In other words, every a only maps to one b. That's the definition of a function. But every b only comes from one a. So it goes both directions. Each one, every a points to a b, every b comes back to a single a. So that's 1 to 1. What about onto? A function is onto if for every element b within that set b, so every element in that b, there is an element a within the first set such that f of a equals b. In other words, every single element in that second set b is mapped to an element in set a. Okay, so those are our two definitions. So let's take the first piece. Let's say that f is 1 to 1. Well, these are finite sets. So I have cardinalities. I have, let's do this in blue. I have A1, A2, all the way out to A sub n. Those are my elements in my first set. Okay. So if this is 1 to 1, then each one of these is going to go to a different, each of these is only going to go to one element. So maybe I've got a B1, a B2, B3, all the way out to B sub n. So it's 1 to 1. If the cardinality is the same, I have the same number of elements in the first set and the second set. So if every element in set A is going somewhere and only one element is going there, in order for every element in A to be mapped to B, every element in B will eventually be mapped to. Everyone will have a pair. Okay, because they have the same cardinality. So that's the definition of onto. Every element in B will be mapped to an element in A. Now, what if it is onto? Well, if it is onto, that means that I'm gonna remove my little arrows here. Oop. Move my little arrows. Okay, now let's say that it is onto. Definition of onto says every single b comes from somewhere. So every b, I could draw a line somewhere up to one of these. We'll call that a sub 3. Now, this is a function. So I can't have two b's going to the same a. I could not have b sub 2 and b sub 1 both going to a sub 1. Otherwise, it wouldn't be a function. So can't have that. But if every b has to go somewhere, well, then every A will have to be taken, because if each B needs a pair and two Bs can't share one, they will each have to have their own. And that is the definition of 1 to 1. So these two things are true if f is 1 to 1, if and only if it is onto.